Good morning, everyone. Let me introduce myself first. I am Mutia Yollanda. I am one of the authors for this research, where this is the collaboration research between Andalas University, especially Department of Mathematics and Data Science, and also National Research and Innovation Agency of BRIN, especially Research Center for Climate and Atmosphere. In this research, we are interested to predict the change, MJO, and extreme rainfall even in Indonesia using the statistical model. And then, especially for this research, we use the VAR model and the correction model of the VAR. So we call it as the VECM model. So to begin with that, I want to describe about the research in general. So for this proportion of incident that happen in Indonesia, it is recorded by BNPB, where the most of the incident in Indonesia, it is cause of the hydrometeorological disaster, such as in this proportion of incident, the flood, it has 37%, and landslide, it has 27%. And then one of the cause, this hydrometeorological disaster, it is because the high intensity of rainfall that occurs. And then the previous research also found that the high rainfall in Indonesia cluster was caused by the large number of the atmosphere circulation that occur in the both of cross equatorial northerly surge and meridional oscillation, or we call as the chains, and also the MJO that can trigger extreme rainfall occurrences over Indonesia. And then this manuscript is also focused on how to build the vector error correction model of change, MJO, and the extreme rainfall event in flooding cluster in Indonesia. And here it is how the division of the rain cluster, where we divide into the flooding cluster in Indonesia because we use global scale atmospheric circulation. The area the cluster division is quite large. And then besides this, also some part of Indonesia are not included in the territorial division due to many ocean areas, such as Maluku and the East Nusa Tenggara. And then this division is just to simplify analysis for the method that we use. It is very important to make the cluster size smaller, which can impact our prediction results or maybe more precise. But it will generate many clusters if we want to divide into the greater than the 14 cluster, and it will be make we are to become more difficult to analyze the data because the impact of the circulation on the many cluster, it is make we are difficult to analyze the results. And then this is introduction of VAR and VECM, where the VAR, it is the advanced model of autoregressive time series model with more than one variables. And using this model, we can recognize the relationship between the variables. And then the VECM, this is the error correction model of the VAR. So if they are the contegration or maybe the long-term relationship between variables, we can use the VECM model, where this model, this general form of VAR and VECM can be shown in the question number 1 and then in number 2. And this is the result and discussions. The result and discussion that we have, we use the daily data for amplitude, change, and rainfall data for flooding cluster in Indonesia. This is starting from January 2001 to December 2019 with more than 6,000 data. And then for this figure, it shows that the Indonesian amplitude change rainfall, it has an up and down trend over time. It means that the time series data of change, MJO, and rainfall in Indonesia are not stationary or do not fluctuate at a certain number. And then it shows a self-transformation step so that the time series data to be analyzed becomes stationary in the variance and also the means. So we need the box chart transformation and augmented equivalent. And then beside, we also shows that the pattern of peak rainfall event in figure shows a clear relationship between the change index and peak rainfall. That cluster rainfall can be seen in 4, 6, 5, and 7. And this is the estimate parameter of FGM. And after we do the estimate parameter by using the maximum likelihood estimations, so we have the significant parameters that are less than 0.05. So it can be used to predict the data in the next future. So this impulse response functions, it is used to know how the impact of the shock, the new shock, into the model. So for the first, it is in the left figure, it is the effect of change into the rainfall in 14 cluster Indonesia. As we know, this figure show how the movement occur due to the shock from the change phenomenon on rainfall in 14 cluster of Indonesia. And it can be seen that before the movement of change, all cluster Indonesia were at their equilibrium point. Then the next period, several clusters began to show their response to the change phenomenon, both positive response that occurred in the cluster 1, 2, 3, and 4. In contrast, the rest gave the negative response to the change phenomenon. But in the next response, some of the rainfall in Indonesia, it start to convert into the equilibrium point. So it will have the stability with the small standard deviation. And then for the effect of MJO in the right figure, we know that it also how to movement occur due to the shock of the amplitude phenomenon on the rainfall in 14 cluster of Indonesia. And as we know, in the first period, this is collected into the equilibrium point, and then for the next step, they are diverged into a positive and negative response, and then after that, it is converged to be the zero, the standard deviation, and then it has to be stability in the same value. And then this is the comparison between VECM and actual, where the actual, it has the red lines, and then the blue line, it is for the VECM model. Where the VECM model, the blue line, it is almost approach the red line, so it means that the VECM model, it is can be used to predict the actual data, because it can be recognized the pattern of the actual data. And then this is the forecasting results that we have in the 1 day ahead in the January 1st in 2019, where the forecasting value, it is in the FGM model, and the actual value, it is in the system value that has recorded by system. And then the conclusion that we have, some of the variable, it has the within range, except the cluster 3, 5, and 10, where maybe this cluster maybe has the other impacts or exogenous variables that can be impact into this cluster. So maybe for the next research, maybe we can include the other phenomenon that can be that have impact into this cluster 3, 5, or 10. And these are the conclusions. The rainfall in the 14 clusters of Indonesia is forecasted to be stable and within the predicted range in the upcoming periods. And then how the performance of these FGM models, it can be performed well in forecasting of change, amplitude of MJO, and rainfall over Indonesia. Therefore, this FGM model is recommended to be implemented in developing the early warning system to mitigate and manage the upcoming hazard in Indonesia. And then for getting better results and more supporting evidence of this performance, however, it is suggested to carry out further this study in predicting the global phenomenon, such as the cold surge, southerly surge, and Indian oscillation dipole, and including the relationship with extremely rainfall Indonesia. So thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.